Look at this stream of alphanumeric codes running through a digital validation scanner. In medical billing, a perfectly accurate clinical diagnosis holds zero weight if its underlying structural syntax fails validation. Coders often assume that claim denials stem from clinical misdiagnoses or missing documentation. However, the bulk of rejected claims are triggered by mechanical syntax errors, submitting a code that violates the strict structural rules of the database. This array visualizes the ICD-10-CM core architecture, designed around a variable length. Valid codes require anywhere from 3 to 7 characters to capture clinical detail. This design requires coders to hit a rigid fixed position target, even as the overall length fluctuates. To consistently report clean claims, you must master the strict structural thresholds of the data array. The World Health Organization authors and directly maintains this global classification architecture. The WHO designed this system to categorize millions of unique health data points across the globe, requiring a precise structural framework to prevent the database from collapsing under its own weight. Health information management professionals access this global framework through the tabular list. Here, broad categories are systematically broken down into highly specific indented subcodes, like the progression from H31 through H33. The physical indentation on these pages represents a strict logical parse tree. Each level you step down into the hierarchy demands a higher degree of structural validation before the code can be finalized. The tabular list functions as a rigid hierarchy. Only the absolute bottom layer of this tree possesses the structural validity required for reporting. Consider this top-down decision tree. At the peak is a 3-character category. This root node provides the base clinical concept, the general family of the disease or injury. From that root, the tree branches downward into 4- and 5-character subcategories. These add layers of necessary clinical detail, isolating anatomical sites or specific manifestations. The reporting rule here is absolute. Categories and subcategories function solely as intermediate steps. If further specificity exists anywhere below them in the tree, these upper nodes are procedurally invalid for reporting. The required targets are the terminal codes. These are the absolute bottom nodes of the classification tree. They represent the maximum level of specificity required by the system. The tabular list enforces this requirement explicitly. Whenever additional characters are available, the instructions mandate that you continue expanding the code to that lowest level. Stopping at an intermediate node guarantees an immediate consequence. The digital clearinghouse will instantly flag the code as incomplete, resulting in an automatic claim denial. In the strict hierarchy of ICD-10-CM, categories and subcategories are merely navigational waypoints. Only terminal nodes possess billable validity. Here is a standard 7-slot data array. Certain sections of the manual, specifically injuries, fractures, and obstetrics, deploy a highly specialized structural requirement known as the 7th character. This final character injects essential clinical metadata into the string. It signals whether the physician is seeing the patient for an initial encounter, providing subsequent care, or treating a sequela. The validity of this character is governed by a strict positional mandate. It must occupy the 7th index of the array. There are 0 exceptions to this placement. This positional requirement does not apply universally. It is absolutely mandatory only when indicated by the notes in the tabular list. A common operational error occurs when coders assume the 7th character simply means the final character. They append it to the end of a shorter code string, regardless of its actual numerical position. The database enforces a systemic penalty for this assumption. Shifting that mandatory character into the 5th or 6th index slot corrupts the entire string, rendering the submission instantly invalid. The legitimacy of a 7th character is derived from its clinical definition and its absolute fixed position within the array architecture. Notice this 5-character array. This creates a mechanical problem. How do you place a mandatory 7th character into position 7 when the terminal base code only contains 4 or 5 characters? Erroneously collapsing the string and dragging the required character into the empty 6th slot violates the positional mandate and triggers an immediate rejection. The database designers built in a dedicated engineering solution for these instances, the placeholder character, X. The X functions as an inert structural spacer. It bridges the gap in the string, preserving the exact indexing of the data field, so the final character lands exactly where it belongs. You will rely on this placeholder bridge frequently when coding poisoning and adverse effects, found in categories T36 through T50. The X also serves a long-term architectural purpose. By locking the character spacing now, the WHO can add new, highly specific sixth characters in the future without altering the foundational syntax of legacy records. The X placeholder holds 0 clinical value. Its absolute necessity lies in enforcing the positional mandate of the array, ensuring your claim passes digital validation. Watch this complete assembly process. Building a structurally sound and fully compliant alphanumeric code array requires 3 distinct steps. First, navigate past intermediate categories, parsing down to the terminal node to achieve maximum specificity. Second, deploy the X placeholder to maintain field integrity whenever structural gaps exist. Finally, lock the required 7th character into its absolute final position to satisfy positional mandates. Submitting partial codes or ignoring rules inevitably leads to repeated claim denials, severe payment delays, and compliance failures. Professional coding requires the rigorous enforcement of data architecture. Structural completeness is the absolute